Okay, let's talk about every math student's favorite topic, which is long division. Thing you remember about elementary school math, and I'm sure you remember loving it. So you'll be happy to know that you can also do long division with polynomials, with x's involved. Before we get there, let's just look at an old school long division problem. So I'm going to take this number 3,835, and I'm going to make this picture that you remember, right? 3,835. And I'm going to divide this number by 8. And remember that when you did this in elementary school, you said, all right, does 8 go into 3? No, too small, can't do it. Does 8 go into 38? Yes, it does. 8 times 4 is 38. And then you would multiply 4 times 8, and you would get 32. And then you would subtract 38 minus 32. And 38 minus 32 is 6. And you would say, does 8 go into 6? No, too small. So I have to bring down the next number. And then I would go through this whole process again. And I would say, all right, I've brought down my 3. Does 8 go into 63? Yes, it goes in 7 times. 7 times 8 is 56. And I'm going to subtract, and I get 7. And then I bring down the 5, and I do it one more time. I'm going to change colors. I'm not really sure why I'm changing colors. I'm just doing it. Bring down my 5, and then I say, does 8 go into 75? Yes, it goes in 9 times. And then we do 9 times 8, and that is 72. And then you subtract. I'm running out of room here. And I get 3. We subtracted there. All right, so we say that you have a divisor of 8. Divisor, yes. And you have a quotient. This is the quotient. Your quotient is 479, remainder 3. The other way we can write that is 479 and 3 parts of 8 remaining, and 3/8. So we took our remainder right here and we put it over our divisor. Okay, so that 3/8 is the remainder over the divisor. And that's another common way of writing these remainders. That's long division. You did that over and over again in the 4th grade or something. Now let's do it with polynomials. So we're going to set this up a very similar way. Okay, we're going to take our polynomial, p of x, and we are going to write it out. So 2x cubed plus 7x squared minus 11x plus 8. And I'm going to divide by this binomial, 2x minus 3. And so I'm going to go through a very similar process. All the steps are the same, you just are doing them with x's. I'm going to look at the first part here, and I'm going to say, how many times does 2x go into 2x cubed? I'm just interested in those first 2 pieces. And I say 2x times what gives me 2x cubed? And that answer is x squared. 2x times x squared gets me 2x cubed. Now I'm going to take x squared, and I am going to multiply it by my divisor. So x squared times 2x is 2x cubed, and x squared times negative 3 is negative 3x squared. All right. Our next step is to subtract, just like we did in the previous step. When I subtract, in the previous slide, that old school long division stuff. When I subtract, I'm going to change the signs, or I'm going to add the opposite. So I'm going to say this becomes a minus and this becomes a plus. If you do this properly, these first terms will always go to 0, okay? Because I've forced it to match, so when I subtract it away, it'll go to 0. Now I have 7x squared plus 3x squared, which gives me 10x squared. And then, like in old school division, you're going to bring down the next term. So I'm going to say minus 11x. And then I'm going to ask that same question again. How many times does 2x go into 10x squared? Or what do I multiply 2x by to get to 10x squared? 2x times 5x gets me 10x squared. And then I'm going to take this 5x and I'm going to multiply it by this whole divisor. So 5x times 2x is 10x squared. Hey, look, it matches. It's supposed to. And then 5x times negative 3 is negative 15x. I'm going to subtract or add the opposite. So this becomes a negative and this becomes a positive. That's gone. Goodbye. And I have negative 11x plus 15x. Negative 11x plus 15x is 4x. And then I'm going to bring down this last term, which is plus 8. And I'm going to go through the process one more time. I'm going to say, how many times does 2x go into 4x? Well, that's 2 times. I'm going to multiply by this binomial. 2 times 2x is 4x. Hey, look, it matches. Again, it's supposed to. 2 times negative 3 is negative 6. I'm going to subtract or add the opposite. So I'm going to go minus plus. That's gone. And I have 8 plus 6, which is 14. So I now have a quotient, which is up here, and a remainder, which is down here. And you can write this answer in a couple ways. You can say that the answer is x squared plus 5x plus 2, remainder 14. Or you could say x squared plus 5x plus 2 plus, because that 14 is positive, 14 divided by 2x minus 3, the remainder over the divisor, just like we did in the last example. Okay, you'll see both of these represented some way. So sometimes I'll use this big R, sometimes I'll use this fraction thing, but they mean the same thing. Okay, let's look at one more example. I want to divide this polynomial by the binomial x plus 3. So something to note is we are always looking at degrees when we're dividing. So this has a degree of 3. If this has a degree of 3, I need my exponents to fall in line. So I need to go 3, 2, 1, 0. But I am missing the linear term, the term that has a degree of 1. So I'm going to need to account for that. The other thing to note is when you are dividing a cubic, because this has a degree of 3, by a linear binomial, which has a degree of 1. So a cubic divided by a linear, think about your old school exponent rules. A cubic divided by a linear should end up being a quadratic. So our answer should have a highest degree of 2. Okay, and that's going to come up again in the future times. So a cubic divided by a linear has a degree of 2. Let's write out this polynomial. 2x cubed plus 4x squared. Now I'm missing that linear term, so what I'm going to do is I'm going to put 0 x's minus 5. Now you see it goes 3, 2, 1, 0. I've represented all those exponents in descending order. My divisor is x plus 3. And I'm going to run through this one more time. So I have x and 2x cubed. How many times does x go into 2x cubed? 2x squared times. 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. I'm going to subtract or add the opposite. So this becomes minus and this also becomes minus. This is gone. 4x squared minus 6x squared is negative 2x squared. And I'm going to bring down this 0x. Oops. Oh, what just happened there? Let's cancel that. Okay. I'm going to bring down this 0x plus 0x. And I'm going to do this again. So how many times does x go into negative 2x squared? Well, negative 2x times. And then I'm going to do my multiplication. Negative 2x times x is negative 2x squared. Negative 2x times 3 is negative 6x. I'm going to subtract or add the opposite. So this becomes plus and this becomes plus. And this is gone. 0x plus 6x is 6x. I'm going to bring down that negative 5. How many times does x go into 6x? Well, 6 times. So that's plus 6. 6 times x is 6x. 6 times 3 is 18. I'm going to subtract or add the opposite. You get it. This is minus. And I say that's gone. Negative 5 minus 18 is negative 23. So that's my remainder because I have nothing left to bring down. So that's my little r. So I can write the quotient of this problem as either 2x squared minus 2x plus 6, remainder negative 23, or 2x squared minus 2x plus 6 minus, because that 23 is negative, 23 over my divisor, which is x plus 3. Okay? And that is how you do polynomial long division.